Okay, everybody, thank you for coming and see you next week. Oh, no, wait. Oh, yes, we only just really started. Well, welcome one and all to a very, very special PESA Presents on Calcite. So, why is this so special? Well, for two really, really good reasons. One, first of all, this was actually the second most requested mineral topic. The first was actually fluorite for this year. Also, two, secondly, because an absolute peach of a guy, one of our longtime members, Johan, hi buddy if you're listening, is better known possibly as, well, Mr. Calcite. That is, when he's off fighting crime with the Justice League. And now that you all know his secret identity, please tell no one. Well, I wanted to do something special for these reasons. So instead of the usual where I go through all of our images from the public domain, like say Wikipedia, Shutterstock, whatnot, and not that there's anything wrong with that, mind you, but I wanted to really showcase some of the amazing people that follow this page and their very great talents. So we went out to our fans and followers, and they submitted a good deal of the following pictures. So thank you very much to all of our page followers and also to all of the folks over at Pennsylvania Rockhounds that gave us a lot of assistance as well. And without any further delay, here we go into the wonderful wide world of calcite. Now, question is, which one do you look at first? Because, well, there's over 800 varieties according to Mindat. Now, Mindat, for those that are new to the field, is an absolutely wonderful source. It is a general website where you can search by whatever mineral your heart desires. Just type in a mineral name, even a fossil name now, and it will come up with the basics, localities, a searchable map, all sorts of wonderful, wonderful things. But according to Mindat, there are literally over 800 varieties of calcite. That's pretty amazing for a mineral that just has a formula of CaCO3. I mean, it seems kind of simple, right? But, well, yeah, it can take a lot of forms. Now, some of these forms are right here. So you look at these. Now, yes, these are from two totally different sites, but still all the same, very dissimilar in appearance at first glance. And then over here, this one I really thought was amazing when she sent it to me. So these specimens from left to right are from Morocco, Connecticut, Medford, and then Kingston, New York. Now, yes, the Kingston one doesn't look very much like the ones on the left, but still, all the same, you have a Morocco specimen next to a Connecticut specimen, and they have the same general sort of shape to them. Now, also, too, if you were wondering, this is the general structure here. So you have the carbon in the middle with 3 oxygens, and then the calcium on the outside. So how did calcite really get its name? Well, it is basically an Anglicization of the German for calx, which in turn is Latin for lime. Now, what amazing awesome sauce person actually came up with that? Well, it's this guy, the great friend of the channel and one of my all-time peeps. I love this guy. He's one of my favorite historical figures. This is Gaius Plinius Secundus, aka Pliny the Elder. Okay, so he didn't end in the best way, but still, you gotta admire the sheer chutzpah of a guy that looks up at Mount Vesuvius and full on apocalyptic, just blowing its top off and goes, you know what? I can take that. So for that, sir, I salute you. You are awesome. Thank you. Now, speaking of awesome, here is the aforementioned Johan. So a thank you again to him and to all the other people that contributed photos coming up and henceforth. So we're just going to look into some of the basic properties of calcite, what it's used for, and also take a look at a lot of eye candy because trust me folks, you got some beauties coming. Now here is one of them, calcite from the Mount Pleasant Quarry. I mean, gosh, that looks nice. I never find anything like that. I won a door prize at one of the last Lulu Temple shows and I almost fainted. I didn't believe them when they called my name. I never win anything. Now, some of the basic properties of calcite. You may see some people say that it has a hexagonal crystal system. That's not true. It really has a trigonal crystal system, but hexagonal axes. It's actually not very hard at all. It has only a hardness of 3. It shows double refraction, which is an optical effect. It has a specific gravity of 2.7102. We're going to get into this in a bit, but it may fluoresce under UV, and if manganese is present, it can be a deep red under shortwave. Now, calcite has polymorphs, which are minerals that have the same exact formula but slightly different characteristics and shapes. So one is aragonite, again, same formula, CaCO3, but it has a hardness of 4 to 4.5 and a specific gravity of 2.9 to 3. Vaterite is another mineral that's a polymorph of calcite and is actually relatively rare. Now, these are some specimens from Teresa Veth here from Palmerton. Now, this shows it under UV light. So on the left, you have without, and then you've got the specimen under long wave, and then a different specimen under short wave. Now, colors in calcite. Showed some of the ones in the beginning that were different colors. How does that happen? Well, it all depends on those impurities. Now, all these additional elements found within, like many other minerals, like say certain ones give sapphire one color, but then a different impurity can give it the color classic to an emerald. So it all depends on what you have. Now with calcite, if you have some cobalt in there, it can give you a dark pink to a purple color. If you got some copper, you're looking at some green. Iron, a yellow gold, kind of like it looks to me like a marigold. And manganese can create a pink color along with several others. Now, aragonite, calcite, and dolomite comprise about 15% of Earth's sedimentary rocks and about 2% of its non-oceanic crust. Now, why is that? Well, calcite occurs in many terrestrial rocks, limestone, marble, travertine, so on and so forth, and marine sediments as well as speleothems, which are cave formations. So yes, these wonderful things right here, whether they be stalactites, stalagmites, flowstone, or cave bacon, bacon, they are often found and made of calcite. Yes, there are other minerals that are found in caves, but still calcite is a very big component of them. Now, where else is it found? It's not just caves. Now, it's located in many environments on its own, often in a massive form or really within rock. They're found in hydrothermal deposits and igneous rocks, metamorphic rocks, sedimentary rocks, and also too as a replacement mineral. Now, this specimen here is globular calcite. This is one of the very few ones that I have in this from Wikimedia Commons still, but I just thought it was a really neat specimen. Now, calcite is highly reactive with weak acids. Note, do this with supervision, if at all. Some frequent viewers to the channel may recognize me mentioning a gal that I went to Geology 100 with. Now, bless her heart, she would either just stick a bunch of acid on every specimen she found or lick it, which is a geologist thing. Trust me, it's not as crazy as it sounds at first, although, again, that I would also not recommend. Now, she cured herself of that the one day when she was going to town on a specimen, looking at it like it was a Tootsie Roll Pop, and it turned out to be a form of asbestos. So, from there on, she just did not stick any acid on anything or did not lick it. And again, I would not recommend that for safety's sake, but famously, calcite does react with many acids. Now, it's often mistaken for dolomite, which is calcium, magnesium, CO3 in quantity 2, but the latter has to be powdered to effervesce. That's a very good difference between them. Now, this is some of the many reactions that it can have when subjected to acid. Now, what causes that effervescent? What causes that little pss of the gas escaping? Well, that's actually CO2. So you have the hydrogen atoms reacting on the calcium, and it splits up into the calcium, water, and CO2. Now, let's play a little game that I call Fun with Identification. So the following is a place that I was actually at a couple of years ago. Absolutely gorgeous. Was as hot as heck. I mean, I could have had two hobbits walking past me looking for Mordor, and I would not have found it anything out of the ordinary. But here it is. So this is a volcanic cone containing large crystals. So let's just say that back in the day, just for giggles, you're an 18th century visitor going into the early 19th. so 1800s roughly. And you're like, what are those? Now, at the time, basic mineral tests were in some circles already known. People did have a generalized idea of hardness and other things. So, what did these people do? Well, they went right out, conducted exacting tests, just tested and tested things again, and they determined the crystals as calcite. Woohoo! Or, okay, maybe they didn't, and they really just ignored the locals that kept telling them time and time and time again that said crystals were not diamonds, and they kept shipping these air quote diamonds that were really calcite are now to go be tested and sold because they kept insisting they were diamonds and they weren't. And that is how Diamond Head on Oahu in Hawaii got its name, because all of these people thought that these calcite crystals were diamonds, and it actually does look very stunning when you hit it in the light. I mean, there's crystals everywhere embedded in this thing. It is phenomenal. Now, not everybody can have the best luck with identifying things. Now, calcite may not be the same as a diamond, but its common occurrence often associates it with other minerals: barite, chalcopyrite, dolomite, fluorite, galena, hematite, pyrite, quartz, siderite, and sphalerite, and really lots of others. Nearly 70 minerals have been found as trace elements in limestone alone. Now, here are some of the uses of calcite, some of the things that we have used it for throughout history. Now, up in the upper left right there, you can see a picture of the Sphinx, which I still say looks like my Uncle Kevin, in its various forms of erosion. It wasn't eroded that way because that part of Egypt was once really, really underwater. No, that's just a really big historical myth that will not die. Problem being is that there were many, many layers of limestone that the Sphinx was built out of. And yes, at one time the area was subject to a lot more water than what it was right now, but nowhere near what some people will tell you. In different ways, different kinds of limestone erode differently. So that is why you have those very, very even but extremely differentially eroded layers on the Sphinx. And speaking of which, if you ever look in a lot of archaeological sources, when they're talking about ancient Egyptian artifacts, they may mention something called alabaster. Now, that can have a lot of different meanings. It can mean calcite. You see, the Egyptians weren't very picky with certain things that they called alabaster or other terms. It could be carved calcite, it could be quartz, it could be any of a small variety of other minerals. They think that it got its name alabaster from possibly the Egyptian goddess Bast. She has a cat head, but really, so if you ever see an artifact and it's labeled alabaster, it may or may not be calcite. It's just something that I saw that people confused a lot when I was looking for images with this, and I just felt I should mention it. Also, too, in the top right is a is a pyramid from Mexico. So a lot of these pyramids throughout the world have been built out of limestone. And then in the top middle, that is the memorial statue to Dr. King, which is made of marble. Then you have somebody that is scattering lime in the fields. Lime is made of limestone, obviously, which then in turn, major component of calcite, and is very, very a needed thing in agriculture still today. It's also used in rubber for tires. It's used in glass making and making plastics, as a water softener in construction stone. Now, right down there is an example of double refraction. Calcite is very much used in optical instruments, and also too, at a very long time, it was a major ingredient in paint. Now, here we are looking at some pretty pictures of the wide world of calcite. So, dogtooth or scalenohedron is a very common form. You're going to see a couple more examples of it coming up. Now, rhombohedral is another common form. This is calcite, dolomite, and gypsum. Now, obviously, like I said, not all specimens are just calcite. Oftentimes, they have different things put into them. Like also too, this one as well, it has hematite and the chalcopyrite to it. And this one that takes an entirely different form altogether. And two, mentioned earlier, pink. Well, yes, calcite can get pink, and here's a specimen right there. Now, this is dogtooth calcite in limestone. And then also too, calcite and celestine, which is the official Pennsylvania mineral from Juniata County. This is calcite from the Mount Pleasant Quarry. I mean, those are just beautiful specimens. I will never get lucky enough to find something like that. Now, the New Paris Limestone Quarry in Bedford County, that is beautiful, beautiful color on that. Just absolutely striking how pure that color is. Here's the New Paris Quarry. Now, up in the left, that purple is actually fluorite, if you're wondering. And with this skull on the right, I really, really tried to put a good Young Frankenstein reference in here. I was thinking of that scene where, you know, they're going through the skulls, freshly dead and whatnot, but I couldn't think of anything concise enough to put in here. Now, the New Enterprise Quarry in Winfield. Now, this middle specimen here is from Blair County. This is the New Paris Quarry. It's calcite and fluorite on a mineralized joint surface. Now, this is from National Limestone, Fulcrowd's Quarry, and also Winfield, different locations for the three specimens. Here we have Mount Pleasant Mill specimen and an iridescent phantom from New Windsor, Maryland. And this is one from Elmwood Mine. So thank you all very, very much for joining. I hope you have a lovely weekend. Go on out there and darn it, have fun and look at some rocks. Thank you very much. Bye.